which was the aquarium in Berlin, which was I believe a Hyatt hotel. It was an unbelievable aquarium. It was like a ring. It was 15 meters high, 45 feet high, 14 meters actually high. And it had an elevator in the center of it, and you could take the elevator ride up and see all the fish. Sometimes they had scuba divers in there cleaning the glass. It was just something that was incredible. And then we had a tragedy where the tank burst and all the water came out with some force, pretty big force you could see in the picture, destroyed most of the hotel. All 1,500 fish perished, and then some of the people were injured as well. There were a few people around that got injured. It was a real tragedy. I'm a scuba diver. I've seen lots of pictures. They had amazing fish in that tank, and some of those fish I've seen while I've been diving. So real sad, very sad thing. But the question that comes out, people said, well, how much pressure did the water exert on the tank? And so what we're going to do is we're going to calculate that. And you can see it's not really a very complicated equation. We just have to multiply three things together and come out with the solution. And so we'll do that now. A few things about the units. It's a lot easier to calculate in metric units and then just convert to stuff that we know in the US like PSI. In order to do that, we just have a few conversion factors to know what a Pascal is, then what a kilopascal is, and then what a kilopascal is, and then what the PSI conversion between PSI and kilopascals is. Not too bad. This is just a arithmetic problem. And so let's do it. So we know that the pressure is the density of the water times the gravity, the force that's pulling down on the water, times the height. The more you have, the more pressure you have, right? It was pretty intuitive. And these are the factors. So the density of water is 1,000 kilograms per meter cubed. Acceleration of gravity is 9.8 meters per second. And then the height of water, which is the height in the aquadome, is 14 meters. So let's start to calculate. So we have pressure equals 1,000 kilograms per meter cubed times 9.8 meters per second squared times 14 meters. Okay, so if we multiply that out, we get that is 137,200. We can cancel some things. These will cancel to this, and that'll be kilograms over meters second squared, which is a Pascal. Okay. Then we want to convert this to kilopascals, so we basically just divide it by 1,000, and we get 137.2 kPa, as we say. And then if we want to convert that to PSI, then we divide it, we multiply it by 137.2 kPa let me fix that. It's a little messy. kPa times 1 psi over 6.9 kPa. And these will cancel, and we will get 19.9 psi. Which isn't a crazy amount of pressure, right? But it's about 20 psi. I mean, you put about 40 psi in your tire, and your house pressure is usually around 60 to 80 psi that's flowing through your house. So it's not an unbelievable amount of pressure like the pressure that's exerted on the Titanic or the bathysphere that goes down to explore the Titanic. Not a crazy amount of pressure. So something else must have happened in this tragedy, and we'll see what it is. But it's not going to be because there was so much pressure that something burst. It's probably going to be some kind of failure with a seal or something like that, but we'll see. So if you like this video and you got some value from it, please subscribe to our channel, click the notification bell. We'll do a lot of other videos coming up. And then if you have some things to say in the comments, that would be great. And then we'll see you next time in the next video. Thank you.